Okay, so let's go with my presentation. Sorry. Share screen. Okay. Okay. So today, this is my outcomes evaluation in electromagnetics. So the title of this is Magnetic Materials. So again, I am Merad A. Lucero, BSECE, and studying in LPU Laguna. So let's go with the discussion. So the main objectives of this is to first is to define the magnetic materials. Second is to different class to identify the different class of magnetic materials, definition and example of different magnetic materials, and magnetic coupling, examples and its application. So what is magnetic materials? So by definition, these are elements that are attracted by magnets, commonly referred to as magnetic. So we all knew of that. Then also, magnetic materials are some materials that can be magnetized to create permanent magnets. So magnets in our refrigerators are examples of these. So also, this can be categorized as magnetically hard and magnetically soft materials. So let's define what is magnetically soft and magnetically hard materials. So magnetically soft is easily magnetized, but magnetism is temporary. So for an example, of magnetically soft, so we are rubbing permanent magnet along a nail or a screwdriver. So this is just an explanation of just an experimentation of this magnetically soft. So as we rub the permanent magnet to the nail, it becomes temporarily magnetized and will emit their own weak magnetic field. So this is because a large number of their iron atoms are temporarily aligned in the same direction by the external magnetic field. So if you already did that experiment or accidentally did that experiment, you can visualize that that scenario. So that is an example of magnetically soft element. So they become temporary magnetic. So the other one is magnetically hard. So magnetically hard materials will remain magnetized indefinitely until demagnetized by opposing magnetic field. So this is also like submagnetically magnetic material. So magnetically hard material can be magnetized by a strong external magnetic field. So we all knew of actually I have already saw this scenario in my experiences in my company and work. So just to cite an example, our company Dyson Electronics PTE Ltd. So we are doing digital motor. So inside of it, there are shafts which are magnetically there is magnet on it, and upon the process, these magnets are are magnetized. So to produce that to produce this to produce our product. So to cite also the difference of this shaft or this shaft of magnetic is of magnet is it has 8 poles. So that is the reason why our Dyson digital motor is really fast. So because it has because it has 8 poles. So that is why it is running in 100,000 RPM speed. Sorry for that noises. So next is the difference is that hard materials will remain magnetized indefinitely. So it will continue to have its magnetic field until they are demagnetized by an opposing magnetic field. So what happens there is if you are magnetizing an magnetically hard material, so it is you will it is you will controlling its magnetic field. So in order to demagnetize that, you will be having the opposite of that magnetic field. So that is the reason why uh, even though they are already magnetized, they become demagnetized because of that scenario. So to cite also an example, I have already saw this and use also this demagnetized machine in my current work, and uh, to have you visualize that it is only a machine or tool that is I don't know if it is all the same, but what I have already used is it is square in shape, and in the middle of that is it is have a circle, so you can put inside of it the material that you want to demagnetize, then applying supply and starting the buttons of that machine, and some cycle time, then it will become demagnetized. I don't know what happens inside and we only knew that it is because of it's applying opposite magnetic field. So that is why the reason it become demagnetized. So just to cite example, and in order for you to visualize this magnetic materials, magnetically soft and magnetically hard materials. So let's move on to the next slide. So this is the different classes of magnetic materials. So because all materials have a different atomic structure, we all knew of that. Different materials react differently when placed in a magnetic field. So in simplest form, magnetic behaviors of a material is determined by its number of unpaired electrons in each atom. So we all knew this, if you have already saw my previous video before, although it is manually made, I have already drawn this structure, but manually. Sorry. So inside, the red one is the nucleus, so it is the main. Then upon it, we close to it is the proton. Then underlying outside it is the electron. So we have many electrons here running in different rotation. So just to make you remember again the structure of an atom. So also, uh, atoms with most elements electron exist in pairs with each electron spinning in a different direction. So that is what I'm talking about. So each electron is running in different in opposite rotation. So there are clockwise, there are counterclockwise rotation. So causing them to cancel out each other's magnetic field. Therefore, no net magnetic field exists. So another is, however, some materials have unpaired electrons which will generate a net magnetic field and therefore have a greater reaction to an external magnetic field. So most materials are classified either as ferromagnetic, diamagnetic, or paramagnetic. So these mainly the three different classes of magnetic materials. So these three, ferromagnetic, diamagnetic, and paramagnetic. So to summarize this, these three materials are the ones who have a greater reaction to an external magnetic field. So that is the reason why these magnetic materials have these classifications. So to go deeper with that, we will be explaining each one of it. So the first one is the ferromagnetic material. So these have some unpaired electrons in their atoms and therefore generate a net magnetic field, albeit a very weak one. So this is because the individual atoms or groups of atoms known as magnetic domains are randomly aligned, canceling each other out. When an external magnetic field is applied to the ferromagnetic material, the individual domains are forced into the alignment which they maintain once their external field is removed, therefore maintaining their magnetism known as remanence. So the term no, the term that we will be using in once we are magnetized these ferromagnetic materials are remanents. So examples of these ferromagnetic materials are iron, nickel, and cobalt. So if you already saw this one, so this is close to the color of the metals that we are using. So metal, steels. So that's examples of that. So internally, microscopically, this is the image of their atoms inside it. Okay. The next one is the diamagnetic material. So diamagnetic materials repel any external applied magnetic field. This occurs because their magnetic domains realign to oppose an externally applied magnetic field when influenced by a magnetic field. All materials show some diamagnetic properties. However, in most materials, the effect is extremely weak and unnoticed. So, just to explain, all of these elements in the in the periodic table of elements are all diamagnetic materials, but there are some which are extremely weak and unnoticed. So, these are the diamagnetic materials. So, all the electrons within the atoms of diamagnetic materials are paired. Therefore, they do not generate their own net magnetic field. So, examples are most elements in the periodic table. So, I did not declare any of them, but there are most elements in the periodic table. Okay, so the image of the atoms inside it is having this reaction. So just for you to remember, just to remember it. So these arrows are all facing down. So this one is uh, unknown pattern. So having an unknown pattern. So next is the paramagnetic material. So paramagnetic materials have a small susceptibility to magnetic fields, so meaning that they are slightly attracted by a magnetic field. However, unlike paramagnetic materials, they do not maintain their magnetic properties once. So the external magnetic field is removed. Most elements are paramagnetic. However, because their attractive force is many thousands of times weaker than paramagnetic, they are also generally considered as non-magnetic. So uranium, platinum, aluminum are examples of these paramagnetic materials. So, in order for you to familiarize more, so in absence of magnetic field, this is what it look like. Then, in presence of magnetic field, this is the image of the paramagnetism. So, this is likely first layer will all be alternating position of all facing up, then all facing down. So this is continuously. So these are paramagnetics are non-magnetic materials. So if you have uh, aluminum materials in your house, so just try to use magnets in it, and uh, you can observe that uh, they are not attracted to it. So because they are paramagnetic materials. Next. So we will be moving on to the magnetic coupling. So a magnetic coupling is a coupling that transfers torque from one shaft to another but using a magnetic field rather than a physical mechanical connection. So just to uh, just to explain uh, explain more. So how does magnetic coupling happen? So magnetic couplings work using the fundamental concept that opposite magnetic poles attract. So this is also same on what I'm explaining earlier about our digital motor work produce. So unlike of it has many folds. So in the image below, this is what I'm saying. So these are having opposite alternating poles. So north south north south north south. So each partner also have this one. So in our digital motor, it has 8 poles, and because of that, when it is magnetized, it rotates in 110,000 rpm. So in based on RDD, they are confident and confidently saying that it can vacuum. So it can vacuum 3 microns of material. So just imagine how small that was. So in able to vacuum that. So I'm proudly saying that I'm really proud that I belong to that group. So I'm really proud that our company is a technology company that really advanced in doing that in producing that high quality home care and personal hygiene products. So sorry, I'm explaining away from this, but just to made an example for you. So also let's go back to the topic. So how does magnetic coupling happen? So the attraction of the magnetic magnets transmits torque from one magnetized hub to another from the driving member of the coupling to the driven member. So torque describes the force that rotates an object. So so what I'm saying is that it transfer torque, but it is not by means of magnetic field, but no physical contact happens. So that is what magnetic coupling is. So to explain more, so we have this example of this is this type magnetic coupling consists of two opposing discs with powerful rare earth magnets. So the torque applied to one disc is transferred to an air gap to an other disc. So typically application includes magnetic mixers and magnetic drive pumps. So these are the examples of this usage of this magnetic coupling. So magnetic mixers and magnetic drive pumps. So I have here the image of what is a magnetic mixer is and a magnetic drive pump. So by concept, I cannot be detailing it to you because I'm not expert of that. But you can refer to this YouTube video so that you can as as you can understand this more. This one I would like to share. This one, the number one is building a magnetic stirrer or vortex mixer. So it is really an interesting topic because also is the YouTube channel is Tech Builder. Then because it is a DIY, so a do-it-yourself project. So actually, I am really intrigued in doing this in the maybe someday if I have the time to do this because it is really easy to do, and I know you will be also happy if you work with this one. So also this is a building number two is the building a magnetic stirrer. I sorry I did not edit this one, but it is a magnetic drive pumps. So the YouTube channel is Liquid Handling Equipment. So you can refer also to this link. So you can, but the main concept of this is to be able to explain shortly and briefly. So this is the driving motor, but this is the pump. So once this rotate, so basically it cannot pump is a liquid material. So basically it is really harmful if there are water will be reaching this part. So because it is electric, so that is why it is dangerous. So to be able to rotate this one, we are having this magnetic coupling here, so that it rotates by means of not having contact with this impeller inside of this one. So when you watch this, when you watch this and click this link and video, you can you can understand this more also. So actually, I have already maintained this one in our company before because I am also before in my previous work before I become a automation technician. I have already become an equipment maintenance technician. So that is why I have already repaired this some kinds of pumps just like this. So it is really an interesting thing to do because you also learn something from it. And I'm really happy now because uh, I've been able to learn this, what happens inside it because of this electromagnetism courses of ours. So basically, this is all my work and what I learned and learned from this video. And thank you very much for watching for this video, and hope you are all doing good for you're all doing good, and thank you very much, and God bless. Okay.